Alright, this is exam review questions number 65 to 69. Alright, so let's get started. Alright, question number 65. We haven't spent a lot of time on this question, much at all. Alright, it says look at the graph of f of x is equal to negative x squared plus 2x plus 8 below. Alright, and use the graph to solve the inequality. Alright, and so when we have this situation, it gives you the equation and then it tells you that the negative x squared plus 2x plus 8, which is this parabola, alright, we want to look for all the solutions that are less than 0, alright, which means that if it's less than 0, we want to look below the x-axis for our answer. Alright, below the x-axis. So, if we look at this graph, and all I'm going to do is just try to reproduce part of this graph real quick. 1, 2, negative 2, and looks like 5. 1, 2, 3, 4, 5. Or this graph goes up here. Alright. If we look at the graph and try to figure out the piece that is below the x-axis, it will tell us our solution. Alright, so in this case, the part that is less than or below 0, below the x-axis, is this piece here. Alright, and this piece here. Alright, and so what you want to do is give the x values where that's part of the solution. So, if we look, this is at negative 2. And the graph is to the left of negative 2. And it's also going to be graphed. This is 0, and this is 5, alright, in the x direction. Alright, it's going to be everything to the left of 5. Alright, those are all the parts that are below the x-axis. Alright, so to write your answer, you're going to say, well, how would you write this? You would say x is less than negative 2. Alright, and the fact that it says less than, we know that it's not including 0. Alright, so we're going to have an open circle there. Alright, and we're going to have an open circle here at 5. Alright, and so this part is x is less than negative 2. And this part is x is greater than 5. Alright? Alright, and that is your solution for this problem. Alright? Number 66 and 67 are two quick problems. Alright? Shouldn't take you much time with them. Alright, it says the solution of this polynomial, the solutions of the polynomial are x is equal to negative 6, negative 1, and 8. Alright, and remember the solutions are pretty much the same as the zeros, alright, the x-intercepts, all those things pretty much mean the same. Alright, so it says write the polynomial in factored form. So once again, all right, if the 0, all right, or the solution is negative 6, then the factor is x plus 6. If the 0 is negative 1, the factor is x plus 1. And if the 0 is 8, then the factor is x minus 8. All right, and we write the polynomial in factored form. And there you go. All right, same thing for 67. The solutions are negative 3, 4, and 7. All right, and if these are the solutions, then the factor form is x plus 3 times x minus 4 times x minus 7. All right, let's keep it going. This one takes a little bit of time. 68. All right. We actually might want to look at the graphs a little bit. Most of this is pretty much an all calculator problem. All right. We want to make sure we put these in correctly. All right. So if I'm putting f of x into y1, I got x cubed divided by 3 plus 3x squared plus 5x. All right, and so let's see if we can put that in here. All right, second plus 712. I just reset the calculator. All right, let's see. This is all pretty much all calculator math. 3 divided by 3. All right, plus 3x squared plus 5x. All right, and let's take a look at the graph. All right, they give us something fairly simple. All right, we take a look at the graph, and the graph goes sort of like this. All right, which means this is a local min. All right, and this value in there somewhere is a, I'm sorry, look at me. All right, that's a local max. All right, and this is a local min. All right, and we want to find those values. They're also asking us about where the graph is increasing and where the graph is decreasing. So let's do a little bit better sketch. All right. Sorry about that. All right, so that's just a quick sketch. All right, but we want to find this value and this value. All right, and so finding those values, let's see. All right, if we're looking for that max, there's a max. All right, local max. All right, we want to go, and it looks like 1, 2, 3, 4, 5. It's somewhere around -5 and -6. All right, so we're going to go second calc max. All right, and since it's somewhere near -5, -6, that maximum. All right, we're going to type in, let's say about -7 for our left bound. Watch it, put our cursor up. All right, and we can put in like -4. All right, and put a cursor there. So the maximum value is definitely between the two. All right, don't want to guess. All right, gives me my maximum, and it tells me my maximum. We're going to write it right on this paper. All right, my local max is -5, 8.3 repeating. All right. All right, if it says 3 decimal places, that's good. That works. You can write 0.333 if you would like. All right, but that works. All right, I want to find my local min. All right, and I do that. Second calc. Second calc min. All right, and it looks like it's almost at 1, a -1 in the x direction. So we're going to say left bound, let's say -3. And we could say right bound 1. All right, it's definitely between those values. We hit enter. All right, and it gives us a local min of -1, -2.3 repeating. All right, or 0.333. All right, so now if we look at our graph, and we can either look at it here or look at it here. All right, this piece right here until it gets to the max is increasing. All right, this from max to min is decreasing. All right, and then it starts to increase again. All right, so we have 2 increasing intervals. All right, and remember, well, I suggest you guys just put an X. Wherever it says increasing, decreasing, just put X. right there. So you know that you're going to use the x component of your ordered pair. All right. So what we're saying is that this value is -1. This value is -5. All right. And so if we treat this as negative infinity, right? We're going all the way to the left. And we treat this as infinity. All right. And we have all our values. All right. We have everything we need. All right. So we're going to say that this graph is increasing from negative infinity over to -5. So we can say from increasing from, use a pencil, negative infinity to -5. All right, and it's also increasing from 1 to infinity. All right, it is decreasing from -5 to -1. All right, and so we can try to do that again for the next, for g of x. All right, so let's put this other equation in. All right, y equals, go x caret 4 divided by 4 minus 2x math 3 cubed divided by 3 minus 5x squared divided by 2 plus 6x plus 4. All right, a lot of stuff there. Let's graph that. All right, and even though we put it in y1 one way, you could put it in there either way. And if you need to pause that to look at the two different ways we put the equation in, you're welcome to. All right, that's besides the point. All right, we have the graph in here. All right, and if we try to sketch that, I just want to try to sketch it over here. I'm not gonna be perfect, but let's see. Kind of looks like it goes through there. Somewhere here. All right, so our graph looks something like this. All right. All right, and that gets the gist of it. All right, we just want a quick sketch. All right, and what we want to do, all right, and all I wanted to be able to do is notice that, well, this graph, the ends both go to infinity, positive infinity or infinity. All right, and so we have some other things that we might want to, well, they're asking us to find. They're asking us to find the maximums. All right, and in this case we have one max. All right, and in this case we have two mins. All right, now, you know, as they said, any local mins. All mins are local mins. All right, there can only be at most one absolute min, and that would be your absolute min in this case. But they just want all their mins and all their maxes. All right, and so let's see if we can get them. All right, second, we're going to start with this min, second calc minimum. All right, it looks like it's about -2. All right, so we want to put in, let's put in -4, enter, to, I don't know, 1. Doesn't really matter. The minimum falls between those 2 points, so go enter. All right, and so it gives us a minimum. The cursors, you can barely see it, but the cursor is hitting it. All right, and so we say that that minimum is, well, these rounds to -2. -2, comma, -8 0.6 repeating. All right, we're going to find this max, second calc max. All right, the max looks like it's at 1, so I'm going to go looking for this max between 1 and, I don't know, -1 and 2. So -1 and 2. There's no science to that. We just want to make sure these cursors are between the point that we're trying to find. We're not going to guess. I'm going to hit enter. All right, and it gives us 0.9999, so that's 1. All right, so it tells us that our max is at 1, 7.083. All right, the 3 is repeating, but you don't have to put that there. All right, and then we're going to find this other min, second calc, again, minimum. All right, it looks like it's at 3. All right, but to be sure, we're going to say second calc min from 2 to 4. 2 enter to 4 enter. All right, it's going to find the min between the two. All right, and that min is at, well, 2.999, so that's 3, comma 1.75. So, and that's a minimum. All right, so it's at 3, comma 1.75. All right, so we're good with our local mins and local maxes. All right, we found those. All right, usually this is why we sketch, so we can write those values. So this minimum was at -2. All right, in the x direction. All right, we're going to put a negative infinity over here. All right, that was at -2. This one was at 1, the max. All right, and this min was at 3. All right, and if we put our infinity here, all right, we have everything we need in order to figure out our increasing and decreasing intervals. So, all right, this piece right here is from left to right going down, so it is decreasing. Ugly color, not working. All right, decreasing. All right, it decreases until it gets to -2. All right, once it gets to -2, it does what? Increase. All right, it increases. All right, until it gets to 1. At 1, it does what? Decrease again. All right, and then from there, it does what? Increase. All right, so let's see if we can write those intervals. All right, we decrease from, or ask us for increasing first. Okay, so from -2 to 1. We're increasing, and we're also increasing from 3 to infinity. All right, we are decreasing from -infinity to -2. All right, and we're also decreasing from 1 to 3. All right, and we're done with that problem. All right, let's keep it going. All right, Sam throws a ball from the top of a building. The table below shows the height of the ball above the ground. All right, so it says write a polynomial function that best fits the data. All right, a couple of different ways we can do this. We start at near the end, we started to talk about finite differences and finding the differences of our y's, or our f of t's in this case. All right, and this will make this problem a little bit easier for us. All right, if we do our finite differences, all right, so we're going to say from 400 to 434 is 34. All right, from 34 to 36 is 2. All right, and from 436 to 406 is -30. All right, and then we go again. All right, from 34 to 2 is a -32. All right, and from 2 to negative 32 is a negative 32. Or from 2 to negative 30 is a negative 32. So this is second degree. All right, and since it's second degree, it is a quadratic. All right, so it says write a polynomial function that best fits the data. All right, so same way we do the finite difference problems. Second plus 712. All right, we're going to put these in our L1. So stat edit 0, 1, 2, 3. All right, put the other values in our L2. 400, 434, 436, 406. All right, and then we're going to go to stat edit. Stat calc. All right, and we're going to choose whatever regression that fits the situation. In this case, it's quadratic. All right, now, this is where I ask you to type a little bit more than maybe some others than just getting the equation. So we go wherever our L, so we go second 1, right, wherever your x's are. Second 2, wherever your y's are, comma. All right, commas between those. Vars, y vars. And we say enter, enter, enter. All right. And what that does is it gives us an equation. All right. So for A, our function f of t, or you can write y, all right, is going to give us negative 16x squared plus 50x, all right, plus 400. All right, now, the good thing about doing that whole L1, L2, Y1 thing is that it puts the equation in Y1 for you, all right? And then you can answer the other questions. Now we want to probably get a good window, all right? And remember, this is a ball being thrown from the top of a building, all right? And the height right here, the highest height is 36, right? So we want to at least go from 0 to, I don't know, 500, all right? Because it's already in the 400s, all right? And we're going to say, we've been saying 0 to 10, and we're going to keep 0 to 10 here, all right? And for our x value, and see what happens. All right, and 0 to 10 works, all right? So there's your projectile, all right, something that was thrown, all right, and we want to find out how high it is after 4 seconds. So we can either go to table or we can go second calc, value, type in 4 seconds, hit enter, all right, and at 4 seconds, all right, it is 344 seconds. I'm assuming that it's feet. It doesn't, oh, it does say feet. All right, is feet high. All right, so there's A, there's B, and then of course I've had, you know it's coming. When does the ball hit the ground? All right, so we want to go second calc, 0. All right. All right, it looks like it might be somewhere around 6. So we're going to go from, I don't know, 0 to 10, maybe. See if that gives us an answer. All right, and it gives us an answer. It tells us that the ball hits the ground at 6.801 seconds. All right. So please try the problem. Don't just copy what I'm doing.